Alright guys, so welcome to your next dose of chemistry. Today we're going to do how to read a periodic table. So how to read a PT. So we're going to go over a sample element here and basically just describe the basic properties with it. So this guy got no, and the element we'll be doing actually is oxygen. So usually a bunch of little squares, and this is as close as I could get it to a square for now. So with this 8 is the atomic number. The atomic number is basically how many protons you have in such an element. So for oxygen it's 8, and then the O is its periodic table abbreviation. You have things like C for carbon, H for hydrogen, Cl for chlorine, and then 16 is the average atomic mass. Now it's the average atomic mass and not just the atomic mass, because it's a combination of the isotopes. So we went over isotopes before, and isotopes are just different numbers of neutrons. So the average atomic mass is a combination of the protons plus the neutrons. And like we said, we'll have varying numbers of neutrons. So if it's, 14.98 or something like that, then that is because there are different neutrons which are involved. So that's how to basically read an element on the periodic table. We'll switch out paper for the next little part, and this will just basically be the whole periodic table in general. I will just go over general positions of things, and I'll do my best to give you guys a little schematic of a periodic table. I don't go to school for art, so forgive me. So we'll have these guys, and this goes up, and then you have one last one right up there. Okay, so we will go with this first. So this is your hydrogen right here, and then helium is over on the other end. These are your first two elements of the periodic table. So there's different groups, and when we go over hybridization or bonding orbitals, this will become important. So I'll just go over it real quick. This is where all your s orbitals are. This is all your d orbitals, and this is all your p orbitals. And then we have something called the actinide and lanthanide series down here, which actually produces f orbitals. So these guys are the alkali metals, so we'll just abbreviate them ALK, and then we'll say metals. General things about the alkali metals: they're silvery, excluding hydrogen, and are usually pretty reactive at room temperature. So sodium comes from here. The most accurate clocks in the world, the atomic clocks, are made out of cesium, which are, I think, CS. Yeah, CS. So most active or accurate clocks in the world come from actually these guys. So cesium belongs in this area, by the way. And then this whole section, it's a big section of the periodic table. These are called your transition metals. So you have iron, you have titanium, you have osmium, all your metals, all your transition metals are in here. And then on this side, now it's not going to be very accurate pictorially, but we'll get the general concept across. There's something called a staircase, and this staircase is on every periodic table. It will divide the periodic table from metals on this whole side, so whole side of the periodic table over here is metals, and then non-metals, I'll go non-Me, are on this side. So obviously there's a lot more metals than non-metals. General things about metals are that they're good conductors of heat and electricity. Non-metals are not good conductors of heat and electricity. Carbon is a non-metal, silicon's a non-metal, oxygen's a non-metal, all the famous guys. So just another quick note is that at the end of the periodic table, this last period, which is a vertical row, they are called the noble gases, and they're not known for being chivalrous or anything, but the noble gases are the most stable gases, and this is because they have their whole valence shell filled. So if you remember what we talked about valence shells, how they're the outermost, it's completely filled up, so it's completely happy, doesn't need any more electrons, so they don't really like to bond with anything. They kind of just exist by themselves. So one last quick tip for this video, anything that ends in "-ine, "-ine", or "-gen", this is just a random fact, but anything that ends in these two things always exists diatomically, which means there are two atoms at all times. So you have oxygen, you have nitrogen, you have chlorine, iodine. Always, 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 you're going to see them in pairs. So these are just general things about the periodic table. If you have any more questions, let me know. Again, my page is the Origin Chemist, and I'll see you guys next time.